In the vast expanse of the cosmos where countless stars and planets reside, humanity has always been driven by a profound curiosity to explore and understand the universe. The year 2010 marked a pivotal moment in our understanding of the universe and our place within it. It was a year that would forever change our perspective on the cosmos. Astronomers announced the groundbreaking discovery of Gliese 581g, an exoplanet orbiting the red dwarf star Gliese 581, located approximately 20 light-years away from Earth in the constellation Libra. This discovery was a significant milestone in the field of astronomy. This distant world, with its intriguing characteristics, sent ripples of excitement throughout the scientific community and captured the imaginations of people worldwide. The potential implications of this discovery were profound. Gliese 581g is classified as a super-Earth, meaning it is larger and more massive than our own planet, but smaller than gas giants like Neptune. This classification alone made it a subject of intense interest. Initial estimates suggested that Gliese 581g is about 3 to 4 times the mass of Earth and possesses a diameter about 1.2 to 1.5 times that of our planet. These dimensions placed it within a range that could potentially support life. These characteristics alone made Gliese 581g a fascinating object of study, but it was its potential to harbour life that truly set it apart. The possibility that this distant world could sustain life forms similar to those on Earth was tantalizing. The discovery of Gliese 581g was not merely a scientific breakthrough, but a cultural touchstone, igniting a sense of wonder and possibility about the existence of life beyond our pale blue dot. It inspired countless discussions and speculations about the nature of life in the universe. It served as a powerful reminder that our solar system is just one tiny corner of a vast and diverse universe, potentially teeming with countless worlds yet to be discovered. The discovery of Gliese 581g expanded our horizons and deepened our appreciation for the cosmos. The announcement of Gliese 581g sparked a flurry of scientific inquiry and public interest, propelling the search for exoplanets into the spotlight. Researchers and enthusiasts alike were eager to learn more about this intriguing world and its potential for habitability. The prospect of finding another Earth, a planet capable of supporting life as we know it, had moved from the realm of science fiction into the realm of scientific possibility. This discovery marked a new era in our quest to understand the universe and our place within it, fueling our imagination and driving our scientific endeavors forward. The discovery of Gliese 581g was the culmination of years of meticulous observation and technological advancements in the field of astronomy. Finding a planet like Gliese 581g is no easy feat. It's like searching for a firefly against the backdrop of a spotlight. Planets, even those much larger than Earth, are incredibly faint compared to their host stars, making them extremely challenging to detect directly. Astronomers rely on indirect methods to infer the presence of these hidden worlds. These methods exploit the subtle gravitational influence that planets exert on their host stars. By carefully observing the star's light, astronomers can detect telltale signs of an orbiting planet. One such method, and the one that led to the discovery of Gliese 581g, is the radial velocity method, also known as the Doppler spectroscopy method. This technique relies on the fact that a star and its planets orbit around their common center of mass. Imagine a dance between two partners of different sizes. The more massive partner, in this case the star, will wobble slightly as the less massive partner, the planet, orbits around it. This wobble, while incredibly subtle, is detectable in the star's light. What makes Gliese 581g so extraordinary is its location. It resides within the habitable zone of its star, Gliese 581, a region where conditions are just right, not too hot, not too cold, for liquid water to exist on the planet's surface. Liquid water is considered a fundamental ingredient for life as we know it, making planets in the habitable zone prime targets in the search for extraterrestrial life. Gliese 581g orbits its star at a distance of approximately 0.115 astronomical units, which is about 1/9 the distance between Earth and the Sun. This close proximity to its star is necessary because Gliese 581 is a red dwarf star, much smaller and cooler than our Sun. The habitable zone around a red dwarf star is much closer in than the habitable zone around a star like our Sun. However, being in the habitable zone does not guarantee the presence of liquid water or life. A planet's atmospheric composition, surface temperature, and other factors also play crucial roles in determining its habitability. While we know that Gliese 581g resides in the habitable zone, much about its atmosphere and surface conditions remains a mystery. Despite these uncertainties, the possibility that Gliese 581g could harbor liquid water and potentially life is a tantalizing prospect that fuels ongoing research and exploration efforts. Section 4. Detecting the undetectable, the radial velocity method. The radial velocity method, also known as the Doppler spectroscopy method, has revolutionized our ability to detect exoplanets. This technique has opened up new frontiers in our understanding of the universe and the potential for finding other worlds. It relies on the principle of the Doppler effect, which describes the apparent change in the frequency of waves, such as light or sound, as the source and observer move relative to each other. This fundamental concept is crucial in various fields, including astronomy, where it plays a pivotal role in detecting celestial bodies. In the context of exoplanet detection, the Doppler effect manifests as a shift in the wavelengths of light emitted by a star as it wobbles due to the gravitational pull of an orbiting planet. This wobble is incredibly subtle, but can be detected with precise instruments. As the star moves slightly towards Earth in its wobble, its light waves are compressed, causing a blue shift. This shift towards the blue end of the spectrum indicates the star's motion in our direction. Conversely, as the star moves slightly away from Earth, its light waves are stretched, causing a redshift. This shift towards the red end of the spectrum indicates the star's motion away from us. Astronomers use sophisticated instruments called spectrographs to measure these minute shifts in the star's light spectrum. These instruments are capable of detecting changes in the star's velocity as small as a few meters per second. By analyzing the pattern and magnitude of these Doppler shifts over time, they can infer the presence of an orbiting planet, estimate its mass, and determine its orbital period. This analysis requires careful observation and precise measurements over extended periods. The radial velocity method is particularly sensitive to detecting massive planets that orbit close to their stars, as these planets induce the most pronounced wobbles in their host stars. This makes it easier to detect larger planets, even if they are far away. This sensitivity makes the radial velocity method a powerful tool for discovering planets like Gliese 581g, which resides in the habitable zone of its star. The habitable zone is the region around a star where conditions might be right for liquid water to exist, making it a prime target in the search for life beyond Earth. Section 5, A World Unknown, unveiling the mysteries of Gliese 581g. Despite the excitement surrounding its discovery, Gliese 581g remains an enigma, a distant world shrouded in mystery. This exoplanet, orbiting the red dwarf star Gliese 581, has intrigued scientists and astronomers alike since its discovery. While we know its approximate mass, radius, and orbital period, much about its true nature remains unknown. These basic parameters only scratch the surface of what we need to understand about this distant world. Unveiling the secrets of Gliese 581g is a daunting task, hampered by the limitations of current technology and the vast distances involved. The planet is located about 20 light-years away from Earth, making direct observation and study incredibly challenging. One of the most pressing questions is the composition of Gliese 581g's atmosphere. Understanding its atmospheric makeup could provide insights into its potential to support life. The presence or absence of certain gases, such as water vapor, carbon dioxide, and methane, could provide crucial clues about the planet's potential for habitability. These gases are often considered biomarkers, indicating the possibility of biological processes. However, directly observing the atmosphere of an exoplanet as small and distant as Gliese 581g is incredibly challenging. The faint light from the planet is often drowned out by the much brighter light of its host star. Another mystery surrounding Gliese 581g is its rotation. Understanding how the planet rotates can provide insights into its climate and weather patterns. Some scientists speculate that the planet is tidally locked to its star, meaning that one side of the planet permanently faces the star, while the other side remains in perpetual darkness. This phenomenon could create a stark contrast between the two hemispheres. Tidal locking can have significant implications for a planet's climate, potentially leading to extreme temperature differences between the day and night sides. This could result in a harsh environment, with one side scorched by constant daylight and the other frozen in eternal night. Unraveling these mysteries will require advancements in telescope technology, such as the development of more powerful space-based observatories capable of directly imaging exoplanets and analyzing their atmospheres. Future missions and instruments will be crucial in providing the data needed to understand Gliese 581g better. Until then, Gliese 581g will continue to captivate our imaginations as a tantalizing glimpse into the possibilities of life beyond Earth. Its mysteries remind us of the vastness of the universe and the many secrets it still holds, waiting to be discovered. Pause 2s, Section 6, the search for extraterrestrial life on Gliese 581g. The discovery of Gliese 581g ignited a spark of hope and curiosity among scientists and the general public alike. Could this distant world, orbiting within the habitable zone of its star, harbor life? The quest to answer this question has led to a surge in scientific endeavors aimed at uncovering the potential for life on Gliese 581g. For life as we know it to exist, certain conditions must be met. The presence of liquid water is one of the most crucial factors. Water is essential for all known forms of life, providing a medium for chemical reactions and a means of transport for nutrients. If Gliese 581g has liquid water on its surface, it significantly increases the possibility of it being a habitable world. Scientists are also interested in the planet's temperature and atmospheric composition. The balance between incoming and outgoing radiation determines whether the planet's surface temperature can support liquid water. An atmosphere that can trap heat through a greenhouse effect similar to Earth is vital for maintaining a stable and warm environment. To detect signs of life, researchers are looking for biosignatures, chemical indicators that could suggest biological processes. These include gases like oxygen, ozone, methane, and nitrous oxide. The presence of these gases in significant quantities might hint at the existence of life forms that produce them. Advanced telescopes and space missions, such as the James Webb Space Telescope and future exoplanet surveys, aim to analyze the atmospheres of distant planets, including Gliese 581g, for these telltale signs. The search for extraterrestrial intelligence, SETI, is another avenue in the hunt for life. SETI projects scan the skies for signals that could indicate the presence of intelligent civilizations. While the focus has primarily been on stars closer to Earth, the discovery of potentially habitable exoplanets like Gliese 581g has expanded the scope of these searches. Despite the challenges, the pursuit of life beyond Earth is a driving force in modern astronomy. The search for life on Gliese 581g is not just about finding another habitable world, it's about answering profound questions about our place in the universe. Are we alone, or is life a common thread that weaves through the fabric of the cosmos? As we continue to explore and push the boundaries of our knowledge, Gliese 581g remains a beacon of hope. The mysteries it holds could one day transform our understanding of life itself. Until then, the search continues, fueled by our innate curiosity and the timeless quest for discovery. Pause 2s. Thank you for joining us on this journey through the cosmos. Stay tuned for more explorations into the wonders of the universe. Pause 2s. Section 7. The future of exoplanet exploration. The discovery of exoplanets like Gliese 581g has propelled humanity into an era of unprecedented cosmic exploration. As our quest to understand these distant worlds continues, innovative missions and cutting-edge technologies are being developed to uncover the secrets they hold. One of the most anticipated advancements in this field is the James Webb Space Telescope, set to revolutionize our ability to study exoplanets. With its powerful infrared capabilities, the James Webb will allow scientists to peer into the atmospheres of distant planets searching for the chemical signatures of life and analyzing their compositions in ways never before possible. Beyond the James Webb, the European Space Agency's aerial mission aims to conduct a comprehensive survey of exoplanet atmospheres. By studying a diverse range of exoplanets, Ariel will help us understand the various conditions under which planets form and evolve, providing crucial insights into their potential habitability. But our ambitions don't stop at telescopes. Interstellar probes, such as the proposed Breakthrough Starshot initiative, are being designed to travel to the nearest star systems at a fraction of the speed of light. These tiny light-powered spacecraft could one day send back images and data from planets around stars like Proxima Centauri and beyond, offering humanity its first close-up look at another star system. Closer to home, NASA's upcoming Nancy Grace Roman Space Telescope will focus on direct imaging of exoplanets. Equipped with a coronagraph, this telescope will block out the light of host stars, allowing us to see the faint glow of orbiting planets. This technology will enable the study of smaller, Earth-like exoplanets and their potential atmospheres. As we look further into the future, concepts like the LUVOIR and Habex space telescopes promise to take exoplanet exploration to the next level. These next-generation observatories will combine high-resolution imaging with advanced spectroscopic capabilities, providing unparalleled detail and insight into the nature of distant worlds. The future of exoplanet exploration is not just about technology, it's about collaboration. International partnerships and interdisciplinary research are key to advancing our understanding of these distant worlds. By working together, scientists from around the globe can share data, expertise, and resources, accelerating the pace of discovery. The journey to uncover the mysteries of exoplanets like Gliese 581g is far from over. Each new mission, each technological breakthrough, brings us closer to answering the age-old question, are we alone in the universe? The future holds endless possibilities, and the quest for knowledge will continue to drive us forward beyond the confines of our solar system and into the vast uncharted territories of the cosmos. Pause 2S. Thank you for joining us on this journey through the cosmos. Stay tuned for more explorations into the wonders of the universe. Pause 2S. Pause 2S, Section 8, the impact of discovering Gliese 581g. The discovery of Gliese 581g has not only revolutionized our scientific understanding, but also stirred profound philosophical and existential questions. This potentially habitable exoplanet challenges our perceptions of life and our place in the cosmos. From a scientific perspective, Gliese 581g has opened new avenues for research. Its presence in the habitable zone suggests that planets capable of supporting life might be more common than previously thought. This realization has fueled the development of new technologies and missions aimed at detecting and studying these distant worlds. Beyond the realm of science, the discovery of Gliese 581g has philosophical implications that resonate deeply within us. It forces us to reconsider our uniqueness in the universe. If life can exist on Gliese 581g, it may exist on countless other planets, reshaping our understanding of life's universality and diversity. This discovery also has a profound cultural impact. It ignites our imagination and inspires art, literature, and media, reflecting our collective curiosity and wonder about the cosmos. Stories of alien worlds and civilizations are no longer confined to science fiction. They are becoming a scientific possibility. Moreover, Gliese 581g challenges us to think about the future of humanity. As we continue to explore and potentially colonize other planets, we must consider the ethical implications of our actions. How will we interact with potential extraterrestrial life forms? What responsibilities do we have to preserve these new worlds? The discovery of Gliese 581g also fosters a sense of unity and shared purpose among humanity. The quest to find life beyond Earth transcends borders and unites people from diverse backgrounds in a common pursuit of knowledge and understanding. It reminds us that we are all part of a larger cosmic journey. Ultimately, the impact of discovering Gliese 581g extends far beyond the realm of science. It touches on fundamental questions about existence, prompting us to reflect on our origins, our destiny, and our place in the universe. As we continue to explore and understand these distant worlds, we embark on a journey not just of discovery, but of self-discovery. Thank you for joining us on this journey through the cosmos. Stay tuned for more explorations into the wonders of the universe. Pause. 2S. Chapter 9, The Challenges of Interstellar Travel. Pause 2S. Section 9, The Challenges of Interstellar Travel. While the discovery of Gliese 581g is a monumental achievement, reaching such distant exoplanets presents an array of technological and logistical challenges. Currently, our space propulsion technology is in its infancy when compared to the vast distances involved in interstellar travel. Traditional chemical rockets, which have taken us to the moon and beyond, are simply not feasible for journeys spanning light years. One of the most promising avenues of research is the development of advanced propulsion systems, such as ion drives, nuclear thermal rockets, and even theoretical concepts like antimatter engines. These technologies could potentially reduce travel times from centuries to decades, making interstellar missions more feasible. However, propulsion is just one piece of the puzzle. We must also consider the logistical challenges of sustaining a human crew on such long journeys. This includes life support systems, radiation protection, and the psychological effects of prolonged isolation in the vastness of space. Another critical aspect is navigation. Even with advanced propulsion, accurately navigating the interstellar medium presents significant challenges. We need to develop precise instruments and techniques to ensure that our spacecraft can reach their distant targets. Additionally, the concept of generational ships, where multiple generations of astronauts would live and die aboard the spacecraft, is being explored. This raises ethical questions about the lives and rights of those born on such missions. The potential for robotic missions is also being considered. Unmanned probes could be sent ahead to gather data, paving the way for future human exploration. These probes would need to be highly autonomous, capable of making decisions and conducting research far from Earth's control. Despite these challenges, the pursuit of interstellar travel is driven by our innate curiosity and desire to explore the unknown. Each hurdle we overcome brings us one step closer to reaching distant worlds like Gliese 581g. The journey to the stars will not be easy, but it is a journey worth undertaking. It represents the next great leap for humanity, pushing the boundaries of what is possible and expanding our horizons beyond our own solar system. Pause. 2S. Thank you for joining us as we delve into the complexities and possibilities of interstellar travel. Stay tuned for more explorations into the wonders of the universe. Pause. 2S. Chapter 10. The Role of Citizen Science in Exoplanet Discovery. Section 10. The Role of Citizen Science in Exoplanet Discovery. While professional astronomers and advanced telescopes have played a crucial role in the discovery of exoplanets, the contributions of amateur astronomers and citizen scientists should not be overlooked. These dedicated individuals, often working with modest equipment and resources, have made significant discoveries that have advanced our understanding of the universe. One of the most notable contributions from citizen scientists is the discovery of exoplanets through the analysis of data from space telescopes like Kepler and TESS. Platforms such as Planet Hunters allow anyone with an internet connection to analyze light curves and identify potential exoplanets. This collaborative effort has led to the identification of numerous exoplanet candidates that might have been missed by automated algorithms. Citizen scientists have also played a vital role in monitoring and confirming exoplanet transit. By coordinating observations from different parts of the world, they can provide continuous coverage of an exoplanet's transit, helping to refine its orbital parameters and characteristics. This global network of amateur astronomers has proven invaluable in the study of exoplanetary systems. In addition to discovering new exoplanets, citizen scientists have contributed to our understanding of the atmospheres and compositions of these distant worlds. By analyzing the light from exoplanets as they pass in front of their host stars, they can help determine the presence of various gases and compounds in the exoplanet's atmosphere. This information is crucial for assessing the habitability of these worlds and searching for potential signs of life. The role of citizen science in exoplanet discovery highlights the democratization of science and the power of collective effort. It shows that anyone, regardless of their background or resources, can make meaningful contributions to the field of astronomy. As technology continues to advance and more data becomes available, the opportunities for citizen scientists to make groundbreaking discoveries will only increase. The collaboration between professional astronomers and citizen scientists represents a new era in the exploration of the cosmos. Together, they are pushing the boundaries of our knowledge and bringing us closer to answering some of the most profound questions about our place in the universe. Thank you for joining us as we explore the vital role of citizen science in the discovery of exoplanets. Stay tuned for more fascinating insights into the wonders of the universe.